Yes, hello viewers. This is J. Murugesan, E for you, Need Physics faculty. And this session, what we are going to discuss is heat and temperature theory and problems. So the first content is Joule's mechanical equivalent of heat. So now you see that. So the first constant, the concept of heat, what we are going to discuss now. Just to see that when you rub the hand, you can feel that heat is produced. So what it says means when you do the mechanical work against the friction between the surface of the hand, then we can get the heat. So therefore, this is the Joule's apparatus. You just see this diagram. This is the Joule's apparatus. When you rotate this handle, what will happen means this is the container which contains liquid or water or any other liquid. So these are the pedals inside this. When we rotate this handle, what happens means the pedal also will rotate, which makes the friction inside the fluid layers, which cause the result of increase in temperature. So the temperature will be measured by using thermometer. So what Joule's concluded, that means the amount of heat produced, let Q be the amount of heat. So the amount of heat produced is directly proportional to the mechanical work done. Or Q is equal to, or Q is directly proportional to W. Therefore, we can say that Q is equal to 1 by J into W. Or from this we can say that W equal to J into Q, where J is called Joule's mechanical equivalent of heat. Yes, that is the constant value. Now, what is the heat means? So, what is the heat energy or simply heat? We know that energy, and it can do the work, capacity to do the work, that is generally called energy. But here the heat energy arises for the substance. How it is means because of the molecular kinetic energy, or due to the motion of the molecules or particles of the substance. Its kinetic energy, their kinetic energy is responsible for heat and the responsible for temperature also. So now just to see that equation, we can see that W equal to J into Q, or J can be written as W by Q also. So the SI unit of heat is SI unit of heat energy is generally Joule, but there is some other practical units or non-SI unit that is like CGS unit. So we can say that is erg also, erg. So that means 1 Joule is equal to 10 to the power of 7 erg. Yes. But in calorimetry, we can again measure the heat energy as in calories. So in calories, in food packet also we can see that. So 1 calorie is equal to 4.18 or approximately 4.2 joules. Okay. So this is the introduction about what is Joule's mechanical equivalent of heat and the heat energy. So the next one is zeroth law of temperature, or the concept of temperature. Before that, you just see that what is meant by thermal equilibrium. So thermal equilibrium means you can say that the two bodies are in thermal equilibrium when their temperatures are equal. That means there is no flow of heat between the objects. Say for example, I can say B and C are separately with equilibrium with the object A or system A. That means A and B are in thermal equilibrium and A and C are in thermal equilibrium separately. So what is the meaning of thermal equilibrium? Means there is no flow of heat, or they are having the same temperature. So that is the word what we are using. So therefore thermal equilibrium means thermal equilibrium. So thermal equilibrium means there is no flow of heat, no flow of heat, no flow of heat between the body or system. So what zeroth law says that when A and B are the two bodies, they are separately in equilibrium. Similarly, A and C are separately in equilibrium. Then we can say that B and C also are in thermal equilibrium. So therefore, what is the necessity of the quantity a temperature T? What we need is, it gives the information about the state of a thermal equilibrium, whether the given system is in thermal equilibrium or not. That means whether there is a flow of heat from one object to another object, or from one system to another system. Now you see this diagram, we just see that this is the hot body. So that means the temperature is very high when compared to the cold body, that is the temperature is less. So generally heat flows in a direction that from as a higher temperature to lower temperature body. Like how the fluid floats from high pressure point to low pressure point, we can say that the heat also produces as a flow from a high temperature, that means from hot body to low temperature, that is a cold body, until there is a temperature difference. Once the thermal equilibrium is achieved, that means these two bodies becomes the same temperature, then there is no flow of heat. And the SI unit of temperature is generally, is Kelvin, but we can use some other practical units like as a Fahrenheit, centigrade, etc. So next one. So the measurement of temperature and the fixed points in the temperature scales. To measure the temperature, practically we are using the device or instrument called thermometers. In thermometer, in laboratory, you saw that mercury thermometer is there, alcohol thermometer is there. Yes, so in that, we are using some liquid whose physical property or the physical parameter may change with respect to temperature. For example, when you hold the alcohol thermometer, when the heat is transferred from your hand to the bulb of the thermometer, then there is an increase in length of this alcohol or mercury column. That means the length of the column, liquid column, is changes with respect to temperature. So for any substances whose property, that is like its length, pressure, volume, resistance, etc., will vary with respect to temperature. So that property which gives the linear variation, such type of properties are used to design the thermometers. So for example, in mercury, there is a linear expansion of the mercury column, one-dimensional linear expansion of the So let us consider X be the any physical quantity. X be the any physical quantity of the substance, any physical quantity. So let us consider for example, if I am taking the Celsius scale, let us consider two fixed reference points. Because in mechanics, suppose we want to measure the position of the object, we must measure its position with respect to origin. That is one fixed reference point. So here also we can use some fixed reference points. Two standard fixed reference points, that is called, one is called LFP, lower fixed point. That is generally called melting of ice temperature, that is 0 degree centigrade or ice point. And next one is UFP, upper fixed point, that is boiling point or 100 degree centigrade. So let us consider X be the any physical quantity whose corresponding value at the temperature 0 degree centigrade is taken as to be X0. So X0 is the value of physical quantity, that may be length or pressure, resistance, whatever may be that, at a particular temperature 0 degree centigrade. At 0 degree centigrade, let X0 be the corresponding physical quantity. And at 100 degree centigrade, that is, this is the lower fixed point and this will be the higher fixed point or upper fixed point, whose corresponding value is X100. At any arbitrary temperature T, let us consider Xt be the physical quantity value at a temperature T. At this temperature, let us assume that there is a linear variation. Between this physical quantity with respect to temperature. I can take that as to be generally Xt equal to At plus B. So we know that this is the equation of a straight line, just like y is equal to mx plus c. So when you draw the graph for that, you just see, so along the x direction temperature is there. Yes, temperature. So temperature is there. Along the y direction, the particular parameter, that is the quantity, is there. So that may be length or resistance or whatever may be. So from this we can say that the slope value is nothing but A, and the y-axis intercept value is nothing but C. So therefore the graph will be like this, a straight line graph. So this is the intersection point, where as per this our equation this will be B, and the slope of the graph. So the slope says something like theta. So the slope of the graph is nothing but the value A, as per our notation. Okay. So now we see that Yes, when x equal to, at the lower fixed point, when temperature has to be 0 degree, then I can get that x naught is equal to, this has to be 0, therefore x naught equal to b. This is the first one, and say this is equation number 1 and this is equation number 2. Now you see that at temperature 100 degree, that is at the upper fixed point value, now you see that the quantity value is taken as to be like x100. That means the value of quantity at 100 degree centigrade or the upper fixed point, then that can be written as 100 into a. So 100 into a plus b is, we already found that that has to be x naught value. So from this I can find out a is equal to x100 x naught divided by 100. Yes, so divided by 100. This is the value of a and this will be value of b. Y-axis intercept as per this equation and slope of the graph. So just take these values, say this is equation number 3 and 2 and 3 are substituted in equation number 1, then we can get that xt, the physical quantity xt, that is equal to a. Instead of a I can write that x100 minus x naught divided by 100 into t, plus b value is nothing but x naught. Okay. So now we see that we want to find out the t value or t equation, just rearrange the term. So therefore t into x100 minus x naught divided by 100, so that is equal to xt minus x naught. Or just to keep the t alone, because that is the equation what we need and was what we have shown here also. We just see that here also we have shown that the same thing here. So now we see that, so t is equal to xt minus x naught divided by x100 minus x naught. This 100 will go to the numerator. So therefore this is 100. Since all the quantities are measured for the Celsius scale, so we can say that this is into centigrade. Yes. So this is the general expression for the temperature in a Celsius scale, where we are selecting the lower fixed point has to be ice point, that is 0 degree, and upper fixed point has to be boiling point of the water, that has to be 100 degree centigrade. So similarly we can consider the another scale, which is a well known one, that is called a Kelvin. Yes. In Kelvin scale, they are taking the fixed reference point has to be triple point of water, that we will discuss in thermal expansion of the liquid concept. But time being, you just consider here the triple point of the water temperature is 273 Kelvin, approximately 273 Kelvin. So in that case, the same expression can be written as to be T is equal to xt divided by x triple point into 273 Kelvin into 273 Kelvin. Yes. So where xt is the physical quantity whose value at temperature T, and the same physical quantity value whose temperature, when its temperature is a triple point temperature of the water. So these two equations are important for the designing of thermometers. Any thermometers, using the these two equations we can design the any thermometer. And go for the next one. Yes. So as we said earlier that there should be a two reference point, fixed reference points in Celsius. Generally a lower fixed point and another one is upper fixed point. So that may be, you just see the diagram. There are three very general popular measuring scales are there. One is Celsius, Fahrenheit and Kelvin scales. So let us consider here x naught. Here x naught is nothing but the value of the physical quantity, as we said, that may be length or pressure or resistance, whatever may be. And this is the upper fixed point value. So when the temperature is 100. Now you see this diagram. When lower fixed point is taken as to be 0 degree centigrade in Celsius, and upper fixed point is 100 degree here. So therefore the total number of divisions between 0 to 100 is 100 divisions. So similarly in the case of Kelvin, the lower fixed point value is 273 approximately, and the upper fixed point is 373 Kelvin. So the number of divisions between these two is also 100 divisions. But in the case of Fahrenheit, the lower fixed point value is 32 degree Fahrenheit, and the upper fixed point is 212 degree Fahrenheit. The number of divisions are 180. So in any, so these are the three standard measuring temperature scales, but you can write the generalized equation. For this case, we can write the generalized equation. That means so x, let x be the any temperature or T be the, we can say anything. So let T be the temperature at any scale minus its lower fixed point divided by, you just see that the value of the quantity at any temperature T and minus this is x naught. So therefore T minus LFP divided by UFP, upper fixed point minus lower fixed point. So that is equal to, this is for any temperature scale, this is the corresponding temperature for any scale, that is equal to. So here the centigrade, the temperature is denoted as C, and whose corresponding lower fixed point is 0 degree, that is C minus 0, divided by upper value is 100 minus 0, that is equal to. Similarly for the Kelvin scale, this will be Kelvin, K means the temperature in Kelvin scale, so minus 273 lower fixed point divided by this is 373 minus 273. So similarly for Fahrenheit also we can write that has to be F minus 32 divided by 212 minus 32. So we just this is the relation. So relation between various temperature scales, relation between different temperature scales, So this is the thing what we must keep in mind for the discussion of the problem. Or the same can be written as to be like this. That means T minus LFP by UFP minus LFP, that is equal to C by 100, that is equal to K minus 273 divided by 100, that is equal to F minus 32 divided by 180. This is the very general expression which relates the different type of temperature scales. Similarly, whenever the temperature is changes, so please go for the next slide. So whenever there is a change in temperature, say for example there is a change in temperature value from 10 degrees centigrade to 20, and what will be the corresponding change in the remaining scales. So for this is the relation for any temperature scales. Similarly, I can write that the relation between various temperature scales is different temperature scales is a change in temperature scale, different change in temperature scales value. So the difference in temperature. In that case, I can write that the corresponding formula, that is delta T, where T means value of temperature at any arbitrary temperature scales. Delta T divided by UFP minus LFP, that is equal to, here delta C by 100, so we can write that delta C by 100. So similarly I can write here also delta K. Why I am writing here that has to be delta C, delta K here means they are having same number of divisions as we said earlier. So that is equal to delta F divided by 180. So this is the relation between change in temperature of the different scales is used for the measuring of the temperature. So kindly note down the theory, students. So this is the thing what we discussed, the relation between various temperature scales and the change in temperature in different scales. So go for the next one. So where there are different types of thermometers by using different properties. For example, in liquid thermometers, just like mercury or alcohol, the change in length of the column is taken as to be the property. So in liquid thermometers the change in length of the liquid column is taken as to be the property x. The property physical quantity x is taken as to be L here. We know that general equation T is equal to xt minus x naught divided by x100 minus x naught. This is the general expression what we derived in the previous topic, 100 degrees centigrade. So instead of x, the physical quantity is replaced by length of the liquid column. Therefore, I can write that T is equal to LT minus L naught divided by L100 minus L naught into 100 degrees centigrade. In the same manner, for Kelvin scale also, I can write the equation here itself. That is in a Kelvin scale. So the temperature in Kelvin scale, the corresponding physical quantity. There we wrote xt divided by x triple point of the water, temperature of the water, triple point temperature of the water. In Kelvin we wrote. So here the corresponding physical quantity is length. Therefore, I can say that T is equal to LT. So that is x is replaced by L, LT divided by L triple point into 273 Kelvin. So this is a general expression for liquid thermometer. Just the same slide, you just see that the another one is there, platinum resistance thermometer. In platinum resistance thermometer, that is a resistance thermometer, the property, the physical quantity is nothing but resistance of the wire or material used. So this is the physical quantity is. In the general expression, just to replace this one, so we can write that T is equal to resistance at T degree centigrade minus R naught, resistance at 0 degree, and R100 minus R naught into 100 degree centigrade. In the same manner, we can write for Kelvin also. For Kelvin, this is for centigrade scale, and this is for Kelvin scale. We can write T is equal to RT by R triple point into 273 Kelvin. Suppose if you are using for Kelvin scale. The next slide is just to see that gas thermometers, because in gas we can say that the volume may be changed or pressure may be changed with respect to temperature. Therefore, in gas thermometer, two cases are there. So for example, in gas thermometer, two things are there. One is we can keep volume as the constant, or we can keep the pressure as to be constant. If the volume is constant, that is the first diagram, what it shows, constant volume thermometer. That means you just take the ideal gas equation, that is PV is equal to RT. If I am taking that mu has to be 1 hour, you can take. If for V has to be constant, if V is constant, then we can say that P is proportional to T when V is constant. This is called constant volume thermometer. In constant volume thermometer, the physical quantity X is nothing but the pressure. Therefore, we can write that has to be the same manner what we wrote there. So that means we can say that in Kelvin scale or in centigrade scale, that is pressure at temperature T and pressure at 0 degree centigrade, like that. So therefore, we can write that, for example, in Kelvin scale, I can write that pressure at any temperature T and pressure at triple point into 273 Kelvin. So in constant volume thermometer, the variable quantity is pressure. Similarly, in a constant pressure thermometer, just to see that the another one is constant pressure. If you are maintaining constant pressure, then in the ideal gas equation is the pressure is constant, then we see that volume is changing with respect to temperature. Therefore, I can say that in this case, P is constant taken outside, therefore V is proportional to T. So in this case, the corresponding physical quantity is nothing but volume of the gas. Again, we can write the same equation or expression either in terms of centigrade or in terms of Kelvin scales. For example, in Kelvin scale, I can write that as 273 into volume at any temperature T, volume at triple point temperature in Kelvin scale. So this is the gas thermometer. These things are so far we discussed liquid and resistance and gas thermometer. They will measure the low temperature ranges. But you see that this is called a radiation thermometer, which works on the basic principle of Stephen's law, that we will discuss in radiation topic. So that is the radiation pyrometer. So the radiation pyrometer is generally used to measure the very high temperature like sun or any distance as celestial bodies. Because the Stephen's law says that E is equal to sigma as a T power 4 Stephen constant. So from this you can say that is E by sigma as a whole power 4 as 1 by 4. Just see that in Kelvin scale. So this is the radiation pyrometer which is used to measure the very high temperature. Go for the next one. And so far we discussed the topics called heat and temperature. Now we are going to do some model problems related to the concept what we discussed now. Now you see that the first question. So what is the value of of the following in the degree Fahrenheit? So say for example that is question number 1. So what we are going to discuss is question number 1. We have to find the corresponding value 40 degree here and 40 degree there, and that should be found in terms of degree Fahrenheit. We know that the relation between is centigrade. So C by 100 that is equal to Fahrenheit F minus 32 divided by 180. So this is the relation between centigrade and Fahrenheit. So therefore by using this we can write this has to be cancelled out by as 20s. Therefore we can write that C by 5. This can be written as to be C by 5 minus F minus 32 by 9. So the value of C is given as to be 40 degree here. Therefore I can write that the value of C is 40 by 5, that is equal to F minus 32 is divided by 9. So it can be as 8 as therefore 72, that is equal to F minus 32. From this we can say that F is equal to so 104, 104 degree Fahrenheit. That is the temperature in Fahrenheit scale, which is equivalent to 40 degree value is 104. You see the second part of the problem, 40 degree difference in temperature. So difference in temperature also we have the expression or relation, that is in difference in temperature. We discussed in difference in temperature. So that is delta C by 100, that is equal to delta F by 180 we wrote. That is the formula what we given for the second part. So again we can write that delta C is equal to delta F, this will be 5 and this will be 9. So we need the delta F value. Therefore delta F is equal to 9 by 5 into delta C. That delta C is given as to be 40 degree difference in temperature. Therefore 9 by 5 into 40 degree, and you just cancelled out is 8 times, and that has to be 72 degree is a Fahrenheit value. So this is the value of difference in temperature as given in the question. Now you please go for the second question in the same slide. So that is a faulty thermometer reaches the freezing point and boiling point. That means as we said the freezing point or ice point is called LFP, lower fixed point, and the boiling point has to be upper fixed point. So this is any arbitrary thermal temperature scales. So we get the expression for any arbitrary temperature scale T minus LFP divided by UFP minus LFP. That should be written in terms of a centigrade scale, correct value of temperature in centigrade scales. So for centigrade we wrote that C by 100. This is the expression what we get. So therefore we just take that the faulty temperature value measured by the thermometer is 60 degree. Therefore you substitute that has to be 60. So 60 minus the lower fixed point is 5 divided by upper fixed point is 95 minus this has to be 5. Therefore C by 100. So we can say that this will be 55 divided by 90, that is equal to C by 100. You just cancelled out, then you will get C is equal to 55 into 10 divided by that is into 10 divided by 9. By simplifying this we can get the value has to be approximately. So by this value, so C is approximately we can get that has to be 61.1 degrees centigrade. So this is the correct temperature measured in the Celsius thermometer. In the same slide, you just see the third question. A temperature of a iron piece is raised from 30 to 90 degree. What is the change in temperature scales on Fahrenheit and Kelvin scales? So you just see that. Again, the formula what we learn is, this is the question number 3. So this is question number 2 and this is the question number 3. You just see that the change in temperature of the centigrade scale, delta C is 90 minus 30, so that is equal to 60 degrees. So that is a 60 degree change in temperature in centigrade scales. Since we know that, so delta C by 100, that is delta K by 100, that is equal to delta F by 180. This is the relation between changing temperature of the temperature in different scales. So as per the question, what they are given here is, so delta C has to be, so this 2b gets cancelled out. First I am taking these two relations. So therefore delta C is equal to delta K. Therefore when the temperature change in centigrade is 60, the corresponding change in temperature in Kelvin also 60 only. Why we are getting the same result means both the scales are having same number of divisions. But you see that in case of centigrade and Fahrenheit, we will get delta F by 180, that is equal to delta C by 100. Or from this we can say that delta F is equal to delta C is nothing but 60 divided by, you just cancelled out, this has to be as 9 by as 5 we will get. So therefore we will get this has to be as 12 times, and we can get that answer has to be as delta F, that is equal to as 12 into 9. So there we can calculate that is so 10 plus 2. It is easy to do the numerical. So 90 plus 18. So 90 plus 18 is 108 degree Fahrenheit. So this is the answer for the third question. Now please go for the another one. Yes, this is the fourth question, 2 ideal. So before that, go to the previous one. And you just see that this last step, what we have written is the value of Fahrenheit temperature scales. Therefore I can write that here, so it's not visible for you. Therefore delta F by is 180, that is equal to delta C by 100. From this we can say that delta F is equal to delta C is 60 divided by, that has to be 100 into 180. So we just do the simplification, you will get delta F has to be approximately 108 degree Fahrenheit. So this is the a change in temperature. Kindly note down the solution, students. So the next sum, yes, question number 4, go to the next sum, question number 4. Just to see that there is a gas thermometer which is used in two ideal gas thermometers A and B. We are using the two gases, one is oxygen and another one is hydrogen. Yes, they are asking what is the data are given in the question. What is the absolute temperature of the normal melting point of the sulfur as read by the thermometers A and B. Just to see that this is we just now studied that is nothing but the temperature in Kelvin scale. For Kelvin scale, T is equal to, here they are telling that yes, the pressure values are given. Therefore, we know that in constant volume thermometer, pressure is varying with respect to temperature. Therefore, we can write that Pt divided by P triple point into 273 Kelvin. Yes. So, therefore, say this is, for example, the gas A or the substance A. So, therefore, Ta is equal to Pt value. For substance A, the triple point water, the triple point pressure is given as to be 1.25. At any normal melting point temperature, at that corresponding pressure is S. So, this is the Pt value. So, Pt value is 1.797 and the triple point value is 1.25. So, therefore, we can write that this has to be Pt value, that is 1.797 10 to the power of 5 divided by P triple point is given as to be 1.25. So, 1.25 into 10 to the power of 5 into 273. So, just to simplify this equation or this value, we can get approximately, the value has to be approximately 392 is 0.46 Kelvin, 392.46 Kelvin. For the gas B, we can see that is a Pt by P triple point. This is for gas B and this is for gas A into 273. Again, you substitute the values. The pressure is 0.287 and the corresponding triple point pressure is 0.2. So, therefore, we can substitute here that that is 0.287 into 10 to the power of 5 divided by the triple point pressure is 0.2 into 10 to the power of 5 into 273 Kelvin. So, 273 Kelvin. So, again, by simplifying this, what you will get is approximately 391.75 Kelvin. So, more or less they are the closest value, but even though they are very closer, there will be a slight difference between these two temperature scales. So, why there is a slight difference between the two temperature scales means in very high temperature only that any normal gases behaves like a ideal gas, but at normal condition that oxygen, hydrogens are not ideally behave. So, because of that property or that reason, that's why there is a slight difference between these two temperatures. Please go for the next question. So, now we see that at what temperature the centigrade, Celsius and Fahrenheit readings are same. We know that the relation between, so this is for question number 4 and for question number 5. Yes, we know that the relation between a Fahrenheit and centigrade, that is C by 100, that is equal to F minus 32 divided by 180. So, what they are telling, say here, if C is equal to, so if C is equal to F, then you can substitute. So, F by S 100, you just cancel out, this will become as to be F by 5, just cancel these two, we F by 5, that is equal to F minus 32 by 9. So, we can cross multiply that to find the value of F. Therefore, 9F by 5 minus F, take this F this side, so minus 32 will be there. So, 5 minus, so therefore, I can get a 4F by 5, that is equal to minus 32, and you just cancel out, this is 8 times. Therefore, we can write that yes, F is equal to, cross multiply this value, 5 into 80, so that is 40, so minus 40. So, for the temperature value minus 40, for this temperature value is minus 40, both Celsius and Fahrenheit scales are same. Go for the next slide. So, kindly subscribe our channel for the a regular updation in the contents and problem solving and theory also. For a very clear theory, all the things are given in exam point of view. So, you can students or any viewers can use it in a beneficiary way. Thank you, students.